it is entirely possible that, for example, for this store and this load, the store doesn't have the address at the time when the load produces the address. And now what do we do? The options for this situation are make loads and stores execute in order. So this load is not allowed to execute until all previous instructions have been completed. That guarantees that at the time when we want to figure out what to do with this load, we have all the store addresses and values, so we can have a situation just like this one here. But of course, that orders these instructions. So for example, loads cannot really proceed. So for example, if this load has been a cache miss and takes a long time, all of these instructions will have to wait for that. The waiting can be reduced by not waiting for all of these instructions to complete. Instead, we just wait for all previous store addresses to be known. Once we know all the store addresses, our load address can be compared with them, and then we know what to do. We either go to memory if nothing matches, we get the value from the store if it is available, or we wait for the store to produce the value if the address matches, but the store is not done yet with its value. The third option is the most aggressive, and it is to just let the load go anyway. So pretty much when we produce the address of the load, we check the addresses of the previous stores. If one of them does match, we wait for it, because clearly going to memory will be wrong. But if none of them match, we ignore the fact that some of them might match once we resolve their addresses. So in this situation, this load will end up going to memory. Now, two things can happen. One is this store resolves to something like 74, in which case we confirm that this was done okay. Or the store might actually get the address of 174, in which case this load loaded the wrong value from memory. In that case, we need to recover this load loaded the wrong value and possibly supplied it to other instructions. So in this case, the stores, when they produce the address, would check whether any of the loads that follow them match the address and were done. And if so, then request a redoing of the load and all of the subsequent instructions to fix the problem of the load loading the wrong value. Most modern processors today actually go with the go anyway option because it produces the best performance. If we let the loads go without waiting for store addresses, it turns out that most of the time we are right. So this most of the time successfully loads the value earlier than if we waited, but occasionally we have a cost of the recovery because we were wrong about this. And then there are entire schemes that try to predict when is this going to happen, let the loads go if it's unlikely, and for loads that often conflict with some store, wait for that store to produce the address before we proceed.